2 years ago, I started a project where I wanted to integrate drones into the fireground. Sharing common information about an incident in the PageTrack system, the various participants in an incident view a graphical user interface, or GUI, that presents just the information relevant to their role in the operation. Responders can look at a phone to see the location of other responders, the drone, any targets the drone pilot dropped to indicate an area of interest, and to see their bearing if they were walking. 100-meter search grids are dynamically created so responders can see what areas have been poorly covered. The drone pilot sees the video from the drone with the location of the responders overlaid on the video. The drone operator can also see the search grids and their center line that should be flown. Other map annotations and hazards the drone must avoid are overlaid on the video. The screen also shows current weather and relevant flight telemetry. Here we see two pictures of the same area from different altitudes and camera angle or gimbal positions. Incident Command gets the big picture and can see where responders are, what areas have been searched, where the drone is, the field of view that the drone operator sees in the drone controller video display, and the path that the drone has flown. This allows the incident commander to direct the drone to areas of interest. If the drone operator sees something of interest, a target can be dropped that responders and incident command can see. Incident command can then direct the closest responders to the area to investigate. The camera here is a visible light color camera. When thermal imaging cameras are used, the drone operator can tell what hotspots are responders and what hotspots might be what they're looking for. I'm also about a month away from having video from the drone displayed in the Incident Command page. From my 2016 proof of concept effort, here's what this will look like. To get this, I tie-wrapped and taped a phone to my drone so I could get the position. Then I added the software to display live video on the Incident Command screen. This functionality will soon be working in the final system. Here we see an actual video of that proof of concept system. The drone launches, shows up, and video from the drone is displayed to the incident commander in UberWatcher. In the final version, as we'll see shortly, the location of responders and the quality of the search grid is also displayed. The telemetry in this proof of concept is off, but we'll see that looking better in a bit. What we do see here is the location of the drone, a yellow line indicating where the drone has flown, and the dynamic grids created as the drone crosses into new 100-meter square grids. Overall, the three types of participants in the incident share information in an intuitive way. Incident Command can manage the scene even though participants are scattered about and not visible from the command post. Let's look at the video showing what the drone operator and Incident Command see. Here we see what the drone pilot sees. This is an app running on an iPad connected to a DJI Phantom P3. The pilot takes off. We start to see the overlaid positions of where the responders are on the video screen. The pilot can also see the 100-meter search grids in blue and a center line that the pilot can fly in red. In the lower right, you see telemetry. So now the pilot is backing up to get a look at what's going on and see where all the responders are. Note down in the lower left, we have the weather information, including the wind direction in blue. The arrow in red is where the drone is pointing. Right now, the drone pilot is just taking a look and seeing what's going on. You can see that as the drone moves, the location of the responders stays in about the same location on the map. Wait a second, what was that in the upper left? A circle or something? We tilt up and we see a keep out area. This might be a tower. It shows up as an ellipse because of the effect of the perspective view. So now the drone pilot continues. When pointing to a true compass point, true north, east, west, or south, the grid is displayed in blue. Otherwise, it's in gray. Red is the center line of the grid. So now let's fly and see what we can see. The drone pilot sees something of interest, moves the crosshairs, and clicks on Drop a Target. Now when we move away, we can see where the target is. More importantly, Incident Command and responders can see where the target is. This helps the drone operations or drone pilot communicate with other people involved in the incident when something of interest is located. So now we're going to fly and just take a look around. Way over in this field, an area that would not be visible to Incident Command, we see we have some responders. There's our tower. Of course, there really isn't a tower. This is just a simulation of the tower location, and so we want to avoid that. Looking back on where we were, we see all of our icons for the responders, the drone launch pad, and other items, including way out on the street, a mailbox location for the driveway. So now we come back around to where we were, since we've flown a very quick search path. Our target is still there. And now it's time to land. The altitude display in the lower left at this particular point in the software development is going back and forth between altitude and AGL. In fact, the entire system works in AGL. I'm just having a little problem displaying that in the software. So now we're going down. You'll note that we got below 100 feet, so we have the altitude or AGL in yellow to warn the pilot that he's too low. And we're going to see that as we drop down, the responder locations stay in approximately the same location. Now we're going to look down and land on the drone pad. Our flight is done. Now let's look at this exact same situation from the incident commander on a web page called UberWatcher. The greenish trapezoid you see is the area that the pilot sees. It tells you what areas of the ground he can see with his camera. If you recall from our flight, we went up in the air, looked around, a little left, a little right, panned up, and then moved the gimbal down. When it points down enough, you can see the area that the pilot is viewing on the ground. Incident Command gets to see the location of all the units on the ground. It also gets to see the 100-meter grids. and the grids are colorized from red, meaning not very well searched, through yellow to green, meaning well searched. An area that is not colored, where there's no grid, well, it isn't displayed. Now you can see we're looking around, seeing what we have. You may recall we took a quick look around, and you can see the trapezoid moving. Here's where we saw that possible obstruction, tilted the camera up, so our trapezoid moved up, and now we're going to continue to look around. Note the telemetry that Incident Command sees in the upper right. Here we see our altitude displayed in AGL. The red arrow shows which way the drone is headed, and we have our weather information. Now we're going forward as we start our search. You may recall that we noted something of interest and dropped a target on it. So now the gimbal is down, so we can look at that area, and we're going to drop a target, and there it is. The drone pilot now pans up a little bit and will continue his flight, searching the area. You may recall we saw those responders way out in the other field. The yellow line is the path that the drone has flown. The red line is the instantaneous direction the drone is going. If the responders were moving, they would have small red lines drawn on top of their icons showing the direction they were going. So Incident Command knows where everybody is and where they are going. When the area of view is a rectangle, the camera is pointing straight down. When it's a trapezoid, the camera has an angle, a gimbal angle to it. So now the drone is going back to land, and we'll see that as it descends, the rectangle gets smaller. And you can see that in the AGL when you see the altitude above ground from the current location. This is different than many drones that give you altitude only relative to the launch point. It does not take into account terrain. This system takes terrain into account. Operationally, if the drone pilot flies at about 200 feet, the pilot can then drop down to investigate anything of interest. The red lines on the overlay are the center line of the grid to help the pilot fly that center line. The blue lines show the grid boundaries. Flights really want to be done on a clean compass point, north, east, west, or south. That's why they are blue when you're on that clean line and gray otherwise. These numbers here are exactly what you get as far as the coverage area when flying at 200 feet at a 45-degree gimbal area. The center line of the video area will be the search grid. Obstructions such as towers can be added into the system and displayed to the drone pilot. The circles around towers show up as ellipses in the pilot view due to perspective of the pilot. You can also enter where power lines are and where other airports might be. In this drawing, this overlay, red is an area that's an active landing or approach area, and yellow are areas where the drone pilot really shouldn't be over 200 feet because it's not known how the pilot would enter the runway, make the approach to the airport. The system also works in altitude above ground, or AGL. The server builds a three-dimensional map of the terrain. The drone can be switched into a mode where it flies at a constant altitude above the terrain. This lets the pilot fly the grid centers and look for people and not worry about any terrain changes that might happen. Since the server knows the drone's location, altitude, heading, and speed, it will be easy to integrate that information into the FAA air traffic control system so that drones are integrated into the national airspace. This will make it possible to use drones during large-scale events that will also have other aircraft involved. The system also maintains all drone flight logs for the maintenance purposes. You can make notes about your flight and equipment use. You can see the path flown for a given flight or see all the paths flown for a given location. There's more work to be done, working on blending in visible light and thermal imaging cameras, but that's the status of the drone project as of January 2018.